YouTube viewers, it is Crystal here. I'm just here this morning because I wanted to give you another video, and the video that I'm going to give you is, or we're going to do a code review in Excel, and what I'm going to give you is the O-ring damage on the Space Shuttle Challenger and find out exactly what happened in this regard. And so what I did was I have taken the data set that I had in Python and R, and I moved that over to Excel. And because the data set was in a CSV file, then I used the text to columns function right here in the data section to convert the CSV file to one column for every element. And that's what it looked like when I used the text to column function. And that's the horizontal, which the horizontal isn't going to do me a whole lot of good. So what I had to do was I had to take the horizontal and I had to convert it to vertical. And how it got converted to vertical, if you do a copy and paste on the paste function, it does give you the ability to paste something in a vertical fashion, which is what I did to convert it to vertical. So now we've got the temperature and the damage in a vertical. So the temperature is in column A and the damage is in column B. So this is going to be a simple linear regression. Column A is your X variable, which is your temperature, and column B is your Y variable, which is your damage to the O-rings. So the first thing that we have done is we have created a chart where we charted out the X and the Y variables. So I'll show you how I did it, but I'm not going to do it because I've already done it. So you come over here where it says insert and it says recommended charts, and we go over here to all charts. You go over here to XY scatterer, and you would go over to this chart right here and you would click OK, and that is going to give you your chart, and that's the chart that I used. And I also wanted to have a regression line on the chart. So you come over here and where it says plus, where it says trend line, and then but we click over here where it says more options. So we have a linear trend line, which is what we want. You can pick other trend lines, but we're clicking a linear trend line. And we also want to display the equation on the chart, and we want to display the R² value on the chart. So you get the chart, the regression line, the equation, and the R² value on the chart. So when you look at the chart, you can do a visual analysis of the chart, which is probably easier to do a visual analysis on this chart than it is to actually look at the numerical figures. But a visual analysis is going to tell you that the lower the temperature, the greater the incidence of O-ring damage. So we had one temperature that was like close to 55 degrees, and it was 11 O-rings were damaged. But in the higher temperatures, you had less O-rings damaged. And the thing is, it's known because I looked on the internet about the Space Shuttle Challenger disaster, and it said that when after the disaster, they had to go back and find out what went wrong, and they found out it was O-ring damage. Basically, these O-rings were made out of plastic, and at low temperatures, the plastic would harden, and so the O-rings were not able to work when the plastic had hardened. And the manufacturers had actually recommended that that the space shuttle not be launched in low temperatures. And that's why at 55 degrees you had 11 O-rings damaged, but at like 80 degrees you had 0 O-rings damaged, which I find to be quite interesting because in my past life in the military I was in electronics, and we had to keep all of the electrical equipment cool. So I was working in a situation that was air conditioned to keep the electrical equipment cool, and with the Space Shuttle Challenger, they wanted the temperature outside to be warm to prevent the O-rings from being damaged. So that was very interesting that it was O-rings that caused the disaster. And I think it was 2 days before my birthday, and I think it was 1986. But you can always look it up on the internet, and they'll tell you exactly what happened, and they will tell you that the O-rings were damaged, and that was the reason for the disaster. And then what we're going to do now is we're going to do a regression on this using Excel. So you can do a regression in Python, and you can do a regression in R, and you can also do a regression in Python. So I'm not going to do it because I've already done the regression, but how you do the regression is you go into Data, and then you go into the Data Analysis module, you click onto Regression, you click OK, and it will ask you what your Y range is. So that's your B column, B1 to B24. It will ask you what your X range is. That's your A column, A1 to 24. These columns have labels, and then it asks you your output range, and I said D2. And then you can check a lot of other things as well, like residuals and normal probability, but I didn't do that. I just did the basics. So I've already done that, so I'm not going to do it again, but I just wanted to show you what happened and how I did it. So this is your summary output. You've got your multiple R, you've got your R squared, your adjusted R squared, you got your standard error, and you've got your observations. So DF is your degrees of freedom. So we had 1 degree of freedom, and the reason why is because we had 2 columns of data, and your degree of freedom in this instance anyway is the columns of data minus 1. So that's going to give you 1. But it depends upon what context you are in as to what your degree of freedom is. SS is sum of squares. I'm not sure what MS stands for. It's your F statistics and your significance of that. So now we've got our coefficients, standard error, T statistic, P value. You got your lower 95%, upper 95%. And then you've got your intercept, which is what we're looking for, and you've got your temperature. So basically, I'm taking a course on Bayesian statistics, and so here's the formula. If you want to calculate the temperature, the lower 95% temperature, it tells you how to do it. It will be E19 minus F19 times T, that's your T distribution, INV, and 0.975 is your confidence interval, higher confidence interval, and E14 which is your residual, which is 21. And then so that gives you the exact same value. And so I didn't come up with this formula myself. Someone who's much more knowledgeable of statistics came up with that formula. But if you want to be able to calculate it, that's how you calculate it. And so the next thing we're going to do is we're going to predict how many O-rings are going to fail at 31 degrees. So I think they said that the disaster happened at 31 degrees, but I was looking on the internet and it happened in Florida. So Florida is not a cold state. And it said it was 55 degrees. So I don't know why this professor said it was 31 degrees. Maybe it was 31 degrees at the landing site or something like that, because apparently there was ice and icicles and things like that. So I'm not sure. I lived in Florida and it wasn't that cold, but apparently it was really cold. And they're saying, even though the internet said it was 55 degrees or something like that, the professor who's teaching this course says it was 31 degrees. So we're going to go with what the professor said. And so it's going to be E18. So that's your intercept coefficient plus E19. That's your temperature coefficient times 31 degrees. And so it's going to be 10.8. So at that temperature, you would have about 11 O-rings damaged. So that's very interesting. If you want to predict how many O-rings are going to be damaged, then that's a good prediction. So what we could do, if you want to see E18 plus E19 times, we'll say 90 degrees. That's typical Florida weather. And it says a negative 3.5, so that means you can't have a negative O-ring. So that means 0 O-rings. So let's say 70 degrees. So that would be 1.32. So again, that would be like 2 O-rings. And let's say 50 degrees. 6.19. So at 50 degrees, it would be, well, definitely 6. I would say 7 O-rings, because you can't have, an O-ring can't be a float. An O-ring has to be an integer. It can't be a float. So that's interesting, that if you want to make a prediction on how many O-rings are going to be damaged based upon the temperature, well, you've got the formula that you can do it. So that's all I wanted to cover in this particular video. We covered the O-ring damage, we covered the temperature, we created a chart, we put a regression line in the chart, we put the regression formula in the chart, we put R-squared in the chart, and we used the data analysis to, what shall we say, perform a regression, which you would be able to do that on Python using stats models or R. And so we've done with Excel what you could do with Python and R as well. So we've covered everything that I'd like to talk about. So I'm going to conclude this video. Thank you so much for watching my video. And if you like my video, please like and subscribe.